welcome back to High Performance Build. We are on Offsite Dirt Network. We are here with Joe, Mark, and Sean, who are our experts in this industry, telling us and sharing information not only about building well, building with components, building with testing, but also actually construction in general. These guys are really, truly the experts out there day to day, working in it and knowing so much about it. So I'm happy to be here with them. And we are talking about with Joe specifically, what are the three things that we need to consider when we're talking about building and construction, in your opinion, Joe?
Well, we're going down to the building science principles, air or heat control, air control, and moisture control. Now that's generally how it's been presented, but I think the moisture component is probably the most important part of that, right? If things are getting wet, almost nothing else matters, right? The expense of handling or managing, wet building components can be exorbitant and should be avoided at all costs. So moisture management is key. Then it's air control, right? I mean, I want to make sure things are airtight before we're starting to worry about other types of heat loss. The amount of heat and moisture that can move due to air leakage is ridiculous. That was one of the biggest eye openers that I had in getting into building consulting and home performance consulting over a decade ago was air control, right? Just the airflow can interact between numerous systems, the building enclosure, the conditioning system, combustion systems in older homes, all kinds of things. It affects air quality. So air control is huge. And then we want to incorporate thermal control as part of that. So, that's nothing. That is the heart of Passive House is super insulated walls, super insulated ceilings, high performance windows, right? We want to limit the heat gain and heat loss of our building enclosure. And then it comes back to moisture, which is vapor control, right? So we start with liquid control first and foremost, then we move to air control, thermal control. But in choosing those materials and how we're going to layer them in our assembly, we have to consider where are we going to put our primary vapor control layer? Is it going to be on the outside in a humid climate like Florida, or is it going to be to the interior in cooler, drier climates like Canada or something like that? So and whether it's being built on site or off site, all of those components need to be integrated into those building assemblies. So, what can you tell us more about that, Sean?
Yeah, Joe, I love how we talk about, right? Because sometimes the building science can potentially get nerdy. And what I love what we do here at the Offsite Network with the great, amazing group of contributors here is how do we break down it so that the masses can understand this? And this is some of those like visual cues. So, like, why does our buildings, our shelter have a roof, right? It's to shed the moisture, that liquid moisture you talk about. So rain, snow, all that kind of stuff. It's got to hit our buildings and get away so that it's not getting inside. But then the opposite is the opposite is inner buildings, we're humans, we're creating moisture. And so showers, kitchens, we're building up moisture and we need to make sure that it doesn't get into our envelope and ensuring that we're aware of what that's doing. And so understanding the liquid and the vapor of how moisture works is critical because that is like really number one. If that's indoor walls and is not able to dry out in the right process, then there's going to be the consequences, which is creating an unhealthy, uncomfortable space. So you're right, bang on when it comes to liquid vapor. I want to talk about another cue, which again is the thermal comfort. And this is just the whole aspect of putting on a sweater. In our old homes that in the wintertime, again, we're kind of talking more cold climate on a lot of the stuff we talk about with Offsite Network here is really looking at sweaters. So for me, I kind of was brought up where in wintertime, we'd either close off a room and not provide heat to that room because that's a waste of energy and created it. And I'd be like, hey, mom, put on the heat. And she's like, no, go put on your slippers and your sweater. So the whole concept of us wearing our toques and ensuring we're providing comfort to our bodies. Well, you know what? Give our homes the sweaters, give our homes the slippers, put on the toques, and ensure that we're keeping that energy we're creating. So again, in cold climate, we're putting on a lot more heat, and so we don't want that heat to escape to the outside. In summer, sorry, in warm climates, again, keeping that heat from the outside getting in. So making sure, again, you've got moisture control, thermal control, and Mark, do you now want to talk about air control?
I do. I like the sweater analogy, Sean, and stemming from Joe's list here, air control, thermal control, starting with moisture control. Um, I look at the simple aspect of you're starting with, let's say we put that windbreaker on, and that windbreaker on us, whether you're running or golfing or strolling down a path, until it's zipped, it's only handling a portion of that air movement. When it's zipped up, when it's hooded up, it's almost all of it. So when outside of a building is that air control, it's that integration of the bottom layer, the walls to the windows and the roof and all those little holes together. That's that outside, but then that inside is a secondary air control layer of everything inside of the building. So once you integrate the ventilation, those doors and windows, is a lot of properties coming together. And so it's marvelous to see that panic layer come about and noticing that the outside is really not a comfortable environment. Noise travels through there, dust travels through there. So it's a fantastic thing, and we like to control it. We like to test our buildings, and that consistency of all those materials coming together, from the membranes to the glazing to to the connectivity and proper install of them. How does that function together? It's so brilliant. So not only what is selected, not only how it comes together, but how it's tested from the field to the factory and enjoyed for years to come.
Beautiful. And I'm looking at it from the perspective of modular. So as many of you may be aware, everything is built in a facility, a manufacturing plant, a factory, as we like to call it. So there are a lot of those key components, moisture, air quality, thermal control, that are all being built within that structure, right? The structures are square because of the wall, like how they're building the wall systems and applying those and building them onto the modular square box. Also, it's indoors, so we're not getting any rain or snow. So we're mostly, there's not any mold or mold function on those. I think the other thing that is really valuable to know, especially in the production or the facility, is the quality assurance and the inspections that are done. Many people might not know that you actually have to have a quality assurance manual for every state that you're building or producing those houses in. You also have to go through all of these state certifications and qualifications in order to build that product. So there are constant inspectors that are inside those factories looking at builds and making sure that they're built to the application of what that building book or that quality assurance manual dictates. So there's a lot of great, processes and programs that go into building those structures. And then if you bring it up one more level to the high performance, as Mark and the team has kind of suggested or we're talking about, how are those panels built and how is the thermal insulation in those panels being dictated? Who's designing it? What kind of level of fun pH are we looking at when we're building those, right? So there are all those elements. It's like earth, wind, and fire, right? We're bringing all the elements together to protect us, to live healthier, and being able to streamline that system all in a build so that the consumer, the client, the person that's living in that home really is enjoying it. So there's so many different tools. There's so many different ways of looking at it. Joe, is there anything that you'd like to kind of recap in this whole process being from, the standpoint of being energy efficient and really looking at those tools of building science?
Test it, test it, test it. Have more eyes on it, right? I tell folks all the time, I'm not coming out here to kick you in the teeth. I'm coming out here to make sure we're building a better building. So, and as long as we're building a better building, hey, everybody's on the same team, right? So, and the only way you get better is by somebody pointing out, where you've come up a little bit short, right? And nobody's perfect the first time through. So, either find your own mistakes or welcome somebody else to help you find your mistakes before you hand that off to your client, right? Nobody wants to, be known as somebody who makes mistakes, but you don't want to leave them behind. Everybody makes them. You don't want to leave them behind. Sean, you had something to contribute,
Yeah,
right?
thanks. So again, when we're talking about building science, it's not rocket science, it's building science. And here the team is being able to break it down quite simple. Audrey's talking about verification. My body is telling me right now I'm too hot. It doesn't need to be something crazy. I know that I'm starting to sweat. That means, again, that I've got to, my body is comfortable. My body's the right temperature. I now need to go to have a shower. After the shower, I need to make sure I'm taking care of the building. I've created moisture. So guess what? Hit that fan. Make sure we're taking care of the buildings by just understanding the basic things. Mark alluded to air control, right? Our buildings are really a balloon. When they've got holes in it, that air is getting out. We don't want our air to get out because that air typically, there's been a lot of money spent for heating that air. So we want to keep that contained. And then, of course, that balloon, it's wrapped in a sweater. That's that thermal control. And of course, we created this building to ensure that it sheds properly. The only tricky part is all of these type of contexts in the building science comes back down to which climate zone you're in. So of course, we got to pull out that it depends sticker because it depends on our climate zone. So it's very critical that all the things that we're sharing today, that the building science applies to the location, location to location. And Joe, I'll let you wrap it up.
Yeah. Like I said, it starts with inspecting on site or in the factory where the components are being built. Then those components are brought together, assembled on site, gotten under roof, gotten dried in a short amount of time. But we need multiple tests on site to make sure that we're fixing problems when those problems are accessible, right? Again, it's about finding where the deficiencies are early. Sometimes they're few, sometimes they're many, but you're catching them while they're cheap and easy to resolve before we're putting on a layer of finish that makes those problems inaccessible and expensive to then correct, right? So let's find the issues early. Let's test and confirm that we've got it right. Let's put in those mechanical systems. Let's commission those, make sure those are dialed in properly. The presence of equipment is not the same as that equipment functioning properly, right? So and too often, code officials are going through with a little clipboard checklist, and I see some tape on the ductwork, it's sealed. I'm like, where's the leakage report, right? Oh, there's a ventilation system. What's the flow measurement on that, right? Is what's coming in equal to what's going out? Let's make sure all that stuff is dialed in and balanced and all the rest of that stuff. So we test to confirm so that at the end of it, we can walk away and say, I can sleep well tonight knowing that everything in that house is going to work the way it was designed to, from factory to finish. And the whole team gets a big pat on the back, and everybody forgets, the fact that we had to seal up some holes and reconnect a wire and adjust a little something, because when we walked away, it was done, right? And those are the kind of folks that we bring together here on the Offsite Dirt Network to help you or help our viewers become more successful in the projects that they're working on, right? To remind you of those things that you probably already know, but maybe somebody needs to remind you, like, oh yeah, we probably really shouldn't skip that commissioning part of it. Let's get those guys back on the books.
I love it. I love it. And Joe, one last thought. Let's leave this with you. Our bodies are our temples. It was so great when Sean was talking so simply about building science in such an effective way. Our bodies are our temples. That's exactly the same thing as our homes. So as you treat your body, you treat your home. We hope that helps you today on Offsite Dirt Network. Check out more high performance builds where you're at along our channel.